My presentation is on Deadlock in Java programs. A little about Java. Java is an object-oriented and class-based programming language. It first became popular because it is a platform-independent programming language. Platform independence allows you to run some code on multiple platforms with little to no changes. For example, if you wrote Java code on Windows OS, you could compile and run it on a Linux OS. Another feature of Java is that it allows for concurrent computing. Concurrent computing is when several computations are taking place at the same time. It sounds very similar to parallel programming, however, they are not the same. Parallel programming requires multiple processors. Concurrent computing, the processes' lifetime overlap, but does not need to happen at the same time. So it is impossible for parallel programming to be done on a single core, while concurrent computing can be done on a single core. There are several problems with concurrent computing. One of them is race conditions. Race conditions is when the output is dependent on arbitrary timing of different events that are out of the programmer's control. Another problem would be starvation. Starvation is when processes do not get the necessary resources. And finally, we have deadlock. Deadlock is when computing processes are blocked because they are waiting for mutually held resources to be released. And an example to demonstrate deadlock is the dining philosophers. If you could imagine, there's a dining table with an arbitrary number of philosophers sitting around that table, and the philosophers can only eat and think. And in order for the philosophers to eat, he or she needs 2 forks, and the number of forks on the table equals to the number of philosophers. And the rules are, before eating, philosophers needs to pick up both forks, and after eating, philosophers needs to set down both forks. So you can see the problem with this is that when all the philosophers, or even more than half of the philosophers, wants to eat at the same time, they will all pick up 1 fork, and they will be left hanging because there will not be enough forks for them to pick up a second one. So this is what you will call deadlock. And here's a more tangible example. This example, we have an 4-way intersection with 4 cars going through the intersection, or trying to go through the intersection. And the problem arises when all 4 cars tries to go through the intersection at the same time. And I have a little demo program to show how this becomes a deadlock. And this is my demo program. There are 2 classes. One is demo 0, which is the main class pretty much. I have a cars class, which builds the cars at the intersection. And within my cars class, I have the car ID, which is labeled int number. The constructor, which takes in an int, and the int becomes the ID of the car. And we have a getter that we can retrieve the ID of the car at any point using this function. And we have a waiting function. This waiting function takes a car's object t, and this object car t is what the car is waiting for, and it basically prints out a statement saying this car is waiting on car t, and after this statement is printed, we can free up the lane for this car, and this brings us to our next function, which is lanes. And car t, it takes in the object cars t, and it basically tells you that this car no longer is waiting for car t. And as we go into demo main, we can see that we're creating 4 different cars. demo 1, demo 2, demo 3, demo 4. This represents car 1, car 2, car 3, and car 4. And we have created 4 different threads. And each thread works for each individual car. So, for example, our first thread, we have car 1, which is waiting for car 2. And then our second thread, we have car 2 waiting for car 3, and the next one is 3 waiting for 4, and 4 waiting for 1. And when we run this program, we can see that it says that car 1 is waiting for car 2, and 4 is waiting for 1, and 3 is waiting for 4, and 2 is waiting for 3. But they never, the lanes never become available. So if we stop this and we go back to the car class, this lanes function never gets called by any of the cars, which means they're stuck in a cycle, and which is basically what a deadlock is. The resources that each one requires is been held by another, so they're stuck there indefinitely. That's what deadlock is. And there are several solutions to deadlock, and one of them is to prevent deadlock from happening in the first place. This is either for programmers to program code that avoids deadlock in the first place, or to design systems so that deadlock is impossible. And another solution is to let deadlock occur, to detect it and break it. And that concludes my presentation on deadlock in Java programs. And here are the sources I used for this presentation.